Now we want to look at finding the equation for all asymptotes and all zero values for the following tangent functions. And if you think back to what we did in the sine and cosine section, there were 3 steps that we followed to find these equations for all asymptotes and all zeros. The first thing that we did is we found the distance between the characteristics. In this case, we're going to find the distance between asymptotes and the distance between zero values. The second thing is we took a known value as our starting value, and the final thing was we put it in the form x equals something plus something times n, where the first blank was our starting value and then the blank in the back was our distance between each value. Now the nice thing about tangent is that every single characteristic is going to be pi units apart when we look at our parent function. With sine and cosine, remember how the zeros were pi units apart but the maxes and mins were 2 pi? With tangent, everything on the parent function is pi units apart. So when we start working at these problems, the distance between characteristics is going to be the period. So we're going to find the period, we're going to take a known starting value, and then we're going to put it into an equation form. Okay. So let's start by working on this first one here. Y equals 2 times the tangent of 4x. First of all, this 2 in front represents a vertical stretch. That has nothing to do with zeros and asymptotes, so I can ignore that piece. The piece I'm interested in is the 4 that's attached to the x. What that's saying is that for every pi units, there are going to be 4 full cycles of tangent being completed. So for my individual period then, pi over b, it's going to be pi over 4. If I originally had pi units as being 1 cycle, and now I need to fit 4 cycles in, it makes sense that every individual cycle is going to be pi over 4. Now we need to look at the zero values. And we're just going to choose a starting zero value. We know that for the tangent value, the x's occur at 0, at pi, at 2 pi, at 3 pi, and so forth. So we're going to find our starting value. And the easiest starting value is to take 4x and set it equal to what we had in our parent function. 4x is equal to 0, which means x will equal 0. I could also find another zero value. 4x is equal to pi, because in my original function I had up here it was 0 pi, then 1 pi, and then 2 pi if we were to continue along. So x equals pi over 4. And if I wanted to take it one more step, I set my quantity inside the new tangent function original or equal to my original 0 from my parent function, which would have been 2 pi. Divide both sides by 4, and that's going to give me pi over 2. So you can see right here my tangent values are now going to have zeros of 0, pi over 4, and pi over 2. And if I look at my period, the distance is pi over 4 in between. So from 0 to pi over 4, that's a pi over 4 distance. From pi over 4 to pi over 2, that's a pi over 4 distance. So I've got a good pattern here. So I know the distance between is going to be pi over 4. I know the characteristics here are 0, pi over 4, pi over 2 for potential starting values. So if I want to know all zeros, I'm going to go in the format of x equals a starting value plus the distance times n, which is the period. So one potential equation could be 0 plus pi over 4n. That's one legitimate answer for all 0 values. Another legitimate answer would be 0 plus taking this starting value, pi over 4 plus pi over 4n, which is my distance times n. Or I could have x equals pi over 2 plus pi over 4n. All those are perfectly legitimate for the 0 values. We'll do the same thing for the asymptotes. We know that my starting asymptotes are at negative pi over 2 and pi over 2. That's what I had here for my parent function, negative pi over 2 and pi over 2. And I'm going to transform those. So I'm going to set 4x equal to negative pi over 2 and 4x equal to pi over 2. And if I solve that, x will be negative pi over 8, or x will be a positive pi over 8. Both of those are perfectly legitimate starting asymptotes. So if I'm going to form the equation for all possible asymptotes, I'll take a starting value plus the distance. And we said our distance is the period. So I could say for the asymptotes, all asymptotes, x equals pi over 8 as my starting value plus pi over 4n. Or I could have said x equals negative pi over 8 plus pi over 4n. That'll give me all asymptotes. The second one here looks a little more complex, but we can rewrite this with the fraction pulled out in front. Y is equal to the tangent of 3 pi over 2 x. And if I want to find all zeros and all asymptotes, I need to find the starting value and the distance. So the distance is the period, so pi over b. 3 pi over 2 is my b value, so pi over 3 pi over 2. If I solve that out, I'll get 2/3. So my b value, or my distance apart, is going to be 2/3. I then need to take a known starting value and solve. So for the zeros, we know for tangent, it's at 0, it's at pi, it's at 2 pi. Always the same thing for the zeros. So I'm going to set my quantity in parentheses, or the piece that's in front of the tangent, back of the tangent, excuse me, equal to 0. And if I solve for x, x is going to be 0. That's the easiest one to work with. I could set it equal to 3 pi over 2. X is equal to pi, because that's a known 0 for my original tangent function. And if I solve for x, I'll get 2/3, which that lines up from 0 to 2/3. That's 2/3 units away. And my period is 2/3. So everything lines up there. So all zeros, x equals a starting value, which is 0, plus my distance apart, or my period, 2/3 n. And the same thing with the asymptotes then. I'll just do one asymptote here. We know that originally the tangent asymptote is equal to pi over 2. So let's just set 3 pi over 2x, which is the quantity inside the tangent function, equal to one of my originals, which is pi over 2. And we solve that out, and we're going to get 1/3. So here's a starting asymptote. I know the distance in between each one is going to be 2/3. So the equation for all the asymptotes is 1/3 plus 2/3 n.